I'll ask you what is the EMF induced. So the current here, let it vary with time like this, I naught t. Let the R be the resistance of this loop. Let the side length of the loop, let it be A. And let lambda be the resistance per unit length of the square loop. Lambda is now I want what is the current flowing in this square loop. Find I kept it nearby, you know. So for this, what happened if I know mutual inductance? This structure I'll call 1, this is 2. So what is the formula? E2 should be equal to, also mutual inductance, M should be equal to E2 into di1 by dt. So if I know E2, then I can calculate the current. So what is I2 is equal to? I2 equal to E by resistance R2. E2. What is the resistance R? Lambda into 4A. So somehow I should get E2. I know di1 by dt. What is di1 by dt is I naught. So what is the end? Everything now? M I naught. So therefore this current I2 should be equal to how much? M I naught by lambda 4A. But we don't know M, no? How to calculate mutual inductance? Again, the flux linking the second coil due to the current in the the first structure. So there's a long wire. I'll assume I think we all know how to calculate flux here. D phi, you take it. So let it be at a distance x. This is dx. D phi 2. Flux linking the strip d phi 2 should be equal to B1 into A dx elemental structure. What is B1? Mu naught I1 mu naught I1 by 2 pi x L A dx. Mu naught I1 L 2 pi A to 2A. So this will be mu naught I1 LA by 2 pi log 2. How you define mutual inductance? This M, flux linking the second coil to the current in the long wire. Di1 by dt. Yeah. Okay, this is I think. So what is I1? I1 equal to I naught t. So that they should be equal to mu naught LA 2 pi log 2. That I'll substitute here. I'll get the current in the loop. So what is value of I2? I2 should be equal to mu naught LA log 2, this I naught by lambda 4A. Just I'll get back this one. Some screen, I only closed it. We are here. No? Okay, this should be the M1. I got it. So now can I calculate the value of I2? Solving this, we'll get the required thing. So here A will get cancelled out. We know lambda, we know I naught. So we'll get the current in the loop here. In what direction the current should flow? Whatever the flow of direction of flow of current. Current is increasing, negative flux increases, define negative EMF induced positive. So the current I2 should flow anti-clockwise. You have to further simplify. I just left it here. So like this, what happens? We can find out the, with the help of mutual inductance, very easy. No, you do one thing. Take out this mutual inductance. Okay? Is there any other alternative method? Please try to analyze. It will be much easier for you. You'll come to know what is use of this mutual inductance. This will be, final answer will be mu naught log 2. A will get cancelled. L I naught by 8 pi lambda. A will get eliminated, only A. So this is the current I2. The same thing can you find out by any other method? Nothing but I should calculate the flux as a function of time here, then I should differentiate. This will be much easier, no? So what it will suggest you, like, irrespective of this current, you know some mutual inductance. Now, what is that current here, no? So if you can get, if you know this value of M, it'll be quite easy for you, no? So to get that E2, what you should do? E2 equal to M into di1 by dt. So like that, for pair of current carrying structures, what I do, I'll calculate mutual inductance so that the calculations part will be easy. Now you think in other way. I'll push a current I in the loop. Can I find out flux linking the wire? Not possible, but this will help us. Means I'll send a varying current. Then a varying current in a loop. Then how much of current will flow in long wire? Can we calculate? There's no other alternative method except mutual inductance. What is the nature of current that I'm going to send in a loop? I know it. Then E1 is equal to what I can write? M into di2 by dt. How much of this I took in other way. So we can also analyze here. I'll send a varying current. Then I'll ask you how much of current is induced in the long wire. So there's no other way. We should come to mutual inductance. Like this, what the mutual inductance will really help us in some very complicated cases. One example is what I shown here now. If you send a varying current in the square loop, how much of current will flow in long wire? We cannot find out. Mutual inductance I can find out. So what I do, E1 equal to M di2 by dt. Problem solved. I'll come to know how much of, I know resistance of this wire. From that I'll calculate the how much of current. Okay, tomorrow we'll continue from here. Thank you all of you.